from a lot of different experts, mainly physics professors at various colleges and universities from all over the world, such as David Bohm, renowned quantum physicist at Princeton University; Carl Pribram, neurophysiologist, Georgetown University; David Albert, Director of Philosophical Foundations of Physics, Columbia University; Richard Feynman, Professor of Theoretical Physics, California Institute of Technology; John Hagelin, Physics Professor at Maharishi University; Stuart Hameroff, Associate Director of the Center for Consciousness, University of Arizona; Nick Herbert, Assistant Professor of Physics, Monmouth College; Michael Ledwith, Professor of Systematic Theology, Maynooth College in Ireland; Andrew Newberg, Director of the Center for Spirituality and the Neurosciences, University of Pennsylvania; Dean Radin, Professor, Saybrook Graduate School; Jeffrey Satinover, Teaching Fellow in Physics, Yale University; Leonard Susskind, Professor of Theoretical Physics, Stanford University; William Tiller, Professor Emeritus, Stanford University; Fred Allen Wolf, author of Taking the Quantum Leap and Parallel Universes; Brian Greene, Professor of Theoretical Physics, Columbia University; and many, many more. But I want to introduce you first to Dr. Amit Goswami. Dr. Goswami is Professor Emeritus in Theoretical Physics at the University of Oregon, Senior Scholar in Residence at the Institute of Noetic Sciences, and author of 9 books on quantum physics, including The Self-Aware Universe and Science and Spirituality, A Quantum Integration. Listen carefully to what Dr. Goswami has to say.
This is the only radical thinking that you need to do. But it is so radical, it's so difficult, because our tendency is that the world is already out there, independent of my experience. It is not. Quantum physics has been so clear about it.
This is the only radical thinking that you need to do. But it is so radical, it's so difficult, because our tendency is that the world is already out there, independent of my experience. It is not. Quantum physics has been so clear about it.
A la segunda. A la primera, volvimos al punto de partida. Deceleramos a 1 metro, 10 elevado a la potencia 0. Ahora reducimos la distancia a nuestro punto de destino un 90% cada 10 segundos. Cada paso es mucho menor que el anterior. Diez elevado a la segunda potencia negativa, la centésima parte del metro, 1 centímetro. Nos acercamos a la superficie de la mano. Unos segundos más y habremos atravesado la piel, cruzando capa tras capa de las células muertas más externas hasta el interior de un diminuto vaso sanguíneo. Capas de piel que desaparecen a su vez, una capa externa de células, el colágeno, el capilar que contiene glóbulos rojos y un blanco y arrugado linfocito. Penetramos en la célula blanca, entre sus organelos vitales aparece la pared porosa del núcleo de la célula. El núcleo contiene los caracteres hereditarios del hombre en las espiras arrolladas del ADN. Dentro de estas espirales más grandes se halla la doble hélice. Al acercarnos llegamos a la doble hélice, una molécula como una escalera torcida, cuyos peldaños de bases pareadas repiten 2 veces en un alfabeto de 4 letras las palabras del mensaje genético. En la escala atómica se hace más visible la acción recíproca de la forma y el movimiento. Enfocamos un grupo corriente de 3 átomos de hidrógeno, enlazados por fuerzas eléctricas con 1 de carbono. 4 electrones forman la corteza exterior del carbono. Aparecen en movimiento cuántico, como un enjambre de puntos vibrantes. 10 metros elevados a la 10ª potencia negativa, 1 ángstrom, y nos hallamos entre esos electrones exteriores. Ahora nos topamos con los 2 electrones interiores en un enjambre más estrecho. Al acercarnos al centro de atracción de los átomos, penetramos en un dilatado espacio interior. Por fin llegamos al núcleo de carbono, tan masivo y tan diminuto. Ese núcleo de carbono está compuesto de 6 protones y 6 neutrones. Nos hallamos en los dominios de los módulos universales. Hay protones y neutrones en todo núcleo, electrones en todo átomo y átomos enlazados en toda molécula, hasta la más remota galaxia. En lo que un solo protón abarca toda la escena, llegamos al límite de nuestro entendimiento actual. ¿Serán estos cuares en intensa interacción? Nuestro viaje nos llevó a través de 40 potencias de 10. Si ahora el campo es la unidad, cuando vimos muchos cúmulos de galaxias reunidos, era 10 elevado a la 40ª potencia, o sea, el 1 seguido de 40 ceros.
You can see that outer space and inner space look very much alike. Lots of empty space. This video was made in 1977. As technology improved, scientists kept going deeper and deeper, and they found smaller and smaller particles and more empty space.
We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly
pops in and out of existence. So, if matter is not solid, and reality is not real, what is this physical universe that we experience and think of as so solid, that looks and feels so real to us? Two models have been developed to answer that question. One is the field, and the other is the holographic universe. We're going to take a close look at both of those models, starting with the field. When we speak of an electron existing as a wave, it isn't like an ocean wave or a radio wave. It is more like a wave of possible locations where the electron could end up as a particle when it is observed. It's a wave of possibilities. This wave of possibilities in which the quantum world exists has been called many names over the years, such as the quantum wave function, which you heard Fred Alan Wolf talk about, the implicate order, which was David Bohm's term, the Planck scale, named after Dr. Max Planck. These scientists apparently like to name things after themselves. The zero-point field, named of course for Dr. Zero Point. The superstring field, and the unified field. Mainly it is just called the field. It is a field of unlimited possibilities out of which everything is created. Lynn McTaggart, author of The Field, defines it as a field of all possibility. In other words, everything you can think of, and everything you can't think of, and everything no one has thought of yet, already exists in wave form in the field.
Progress in our understanding of the universe through physics over the past quarter century has been exploring deeper levels of natural law, from the macroscopic to the microscopic, from the molecular to the atomic to the nuclear to subnuclear levels of nature's functioning, so-called electroweak unified scale, grand unified scale, super unified scale. And what we've discovered at the core basis of the universe, the foundation of the universe, is a single universal field of intelligence, a field which unites gravity with electromagnetism, light, with radioactivity, with the nuclear force, so that all the forces of nature and all the so-called particles of nature, quarks, leptons, protons, neutrons, are now understood to be just different ripples on a single ocean of existence. It's called the unified field or superstring field. a single universal field of intelligence, an ocean of existence, at the basis of everything, mind and matter. And all the so-called particles of the universe, the forces in our universe, everything in the universe are just ripples on that ocean of existence. That's the unified field. And that field is a non-material field. Planets, trees, people, animals, we're all just waves of vibration of this underlying unified superstring field. We're really living in a thought universe, a conceptual universe. Quantum mechanics is just play and display of potentiality. So the point I'm making is the deeper you go in the structure of natural law, the less material, the less inert, the less dead the universe is, the more alive, the more conscious the universe becomes. Then when you get to the foundation of the universe, the unified field or superstring field, it's simply a field of pure intelligence. Intelligence because it's the fountainhead of all the laws of nature, all the fundamental forces, all the fundamental particles, all the laws governing life at every level of the universe have their unified source in the unified field. That makes the unified field the most concentrated field of intelligence in nature. Non-material, dynamic intelligence. Those are the properties of the unified field. So, as you said, the tighter physics have tried to grasp onto physical reality, to understand what it's really made of. What are the core building blocks of life? At the basis of it all, life, the universe, slips through your fingers. And you come up with something that's increasingly abstract to come to the realm of pure abstraction. And that's what the unified field is. It's pure abstract potential, which rises in waves of vibration to give rise to the particles, the people, everything we see in the vast universe.
So, the field is a place outside of space and time where everything, all possibilities, already exists, but only in wave form. This field does not contain particles. It is not matter. It is not part of the physical universe. Instead, it is what the entire universe is made from these waves of possibilities.
Physicists give this a name. They call it a quantum wave function because it seems wavy. However, this wave function isn't just a wave of matter, like an ocean wave or a sound wave or any kind of wave of matter. It's a wave of possibility. It's a kind of thought wave. And because it is a wave of thought or possibility or not matter, it's invisible to us. But we can't explain what we do see as matter in these small corners of space and time unless we picture that these matter particles somehow come out from or emerge from these thought wave patterns which are invisible to us.
Meet Captain Quantum.
And here we are, the granddaddy of all quantum weirdness, the infamous double-slit experiment.
The first people who did these experiments, and these experiments of, crude experiments of this kind, were first performed almost 50 years ago, or more, 60 years ago. Those people were flabbergasted.
To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So, they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like waves.
Let's make sure we understand this double-slit experiment so far. When we shoot matter, like a BB or a marble, at a barrier with two slits, we get two bright streaks on the screen behind in line with the slits, like this. And when we shoot waves, like waves of water, through a barrier with two slits, one wave becomes two waves on the other side of the barrier, and when two waves hit, they interfere with each other. If the top of one wave aligns with the top of another wave, it's called constructive interference, and the result is a new and bigger wave. But if the top of one wave aligns with the bottom of another wave, it's called destructive interference, and the result is that they cancel each other out, and there's no wave at all. And when constructive and destructive interference happen together, you get an interference pattern on the back screen that looks like this. Now, if we shoot an electron, which we have always thought of as a particle, a little piece of matter, through a barrier with two slits, you would think we would get a pattern on the back screen that particles make, like this. But we don't. Instead, we get an interference pattern that waves make, like this. The conclusion is that electrons, which are the building blocks of what we call reality, are not solid particles at all, but exist as waves as well. In this wave form, they are called quanta, which is why the study of how they behave is called quantum physics. But that's not the end of the double-slit experiment. Let's rejoin Captain Quantum where he left off.
The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like waves. Physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched.
So the electron is very peculiar. The electron is very peculiar in the sense that when you are not looking, electron can be here, can be there, or can be over there in the corner of this room. It can be all over this room, so to speak. But whenever we look, this is the strange thing about these electrons. So whenever we look, we always find them to be in one particular Geiger counter, although we may have a room full of Geiger counters. We never hear the Geiger counter sticking all over the room. This is the fundamentally important stuff about the electrons.
It was here that physicists stepped forever into the strange never-world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
Particles aren't really what they seem to be. They're momentary manifestations, momentary poppings of this deeper imaginary realm, this wave-like realm, this implicate order, as David Bohm would say it, this quantum wavy function, as quantum physicists might talk about it, in which there is no particle. There's just this waviness which can spontaneously pop out as particles.
Once again, let's make sure we understand, because this is so important.
alineación con el toroide esconde la clave para el acceso a una nueva forma de energía limpia y segura, imaginemos las consecuencias. Este podría ser el avance tecnológico más importante de nuestros tiempos. ¿A quién no le gustaría tener una fuente de energía ilimitada y plenamente disponible? Esa es la pregunta clave.